Let's now go back. Right, so this is the proof that we just discussed in complete details. You can definitely refer to it. And I would like to make a final remark just to say that you should really know about why this version of the proof actually succeeded and why the previous proof actually failed. And of course, what would make a difference is about the introduction for the axiom, d larger than 0. And every time if you want to fix for the deadlock freedom proof obligation, you don't necessarily really just have to introduce a new axiom in order to fix it. It just happened that in this particular case, for our initial model, we can fix it just by adding the extra axiom. But you may have to fix other part of the model for other system or for other version of the model. And we have arrived in the final version of our initial model. And we say that the final version of our initial model is provably correct. But every time if you claim that your model is actually correct, you have to give the context. What are exactly the criteria you actually use to really judge about the correctness of your model? So we got 3 criteria, remember. And we got number 1, the establishment of the invariance. To achieve it, we actually introduce the proper init events to really initialize the variables for the system. And the second criterion is about the preservation of the invariance. And the way we fix this proof obligation is by introducing guards to our 2 events. Again, you don't necessarily have to, every time if you want to fix the invariant preservation proof obligation, you don't necessarily just have to add the guards to the events. It just happened that in our particular case here, we have to fix the guards. But it may have to fix other parts in order to fix the invariant preservation proof obligation. And what we just did is about deadlock freedom. And for this one here, it happens that to really fix this issue here, we have to introduce a new axiom to say d should be strictly larger than 0. Right? So these are the 3 criteria that we have got so far. And these are the 3 achievements we actually we were able to get from our initial model. And that's a summary of everything about the initial model. I would like to just highlight very quickly about the different parts so that when you study later, you can also refer to the highlights quickly. Okay, so that's the final version of the initial model, and you got constant, you got axiom, you got variables, you got invariants, you got the init events, you got whatever, however many events you have. In this case, we got 2, right? 2 events according to this particular abstraction, right? And we got 3 correctness criteria. Invariance, either to establish it or to preserve it, and also deadlock freedom. Let's now talk about one by one quickly. And what about in the case of invariant establishment? And this one over here is really about by properly defining some init events. In this case, we simply just initialize the variable value n to be 0 over here, right? Right. So this part over here is really for invariance establishment. All right, and then let's talk about the second correctness criteria. And the second one there is invariant preservation, right? That's also very important. And it happens that the way we did it is by adding guards to our ML_out and also ML_in events. So these are the 2 necessary fixes for our case for invariant preservation. Again, let me emphasize, whenever you want to fix for invariant preservation, you don't necessarily have to just fix the guard, right? It just happened that for our initial model, by fixing the guards, we were able to fix this, but not vice versa, right? Just let me emphasize that. Right, so these 2 happen to be the fixes for invariant preservation, right? Invariance preservation. Right, the final one is about the deadlock freedom over here. So what exactly do we do in our case to fix the deadlock freedom? We introduce this particular axiom to make sure we were able to say that disjunction for all the guards is not equivalent to false, right? That's what we did. Okay, let me write it down. So this is what we did to really fix for the deadlock freedom. And also the so-called non-blocking property. That's about it for our initial model for the bridge controller. But if you recall, what we said in the very beginning when we first introduced to you the bridge controller, we actually got 4 models to actually go over. This will be just the initial model. And we got 3 subsequent refinements to really consider. And we're going to go over one by one. All right. All right, so now you can review about the initial model. That's it. And let's now move on to our first refinements. By somehow we want to, let me give you a very quick heads up. Look ahead. We want to somehow add some concreteness into this initial abstraction. Rather than having the island and the bridge as an entire compound, we want to split it into just the island and also the bridge. That's what we want to do. Rather than having a single compound, we want to say we want to have island and also we want to have bridge. And accordingly, we're going to define the necessary details in order to really specify and also to really prove the corresponding correctness criteria. That's something we'll do. All right, stay tuned. I'll see you in the next part.